Hi, Al Williams here. Thought I'd show you a little bit about what I've been doing with the RC Fourth from Mike Riley. Actually, Glenn Jolly made some modifications that were very similar to ones I'd been thinking about, and so that got me to thinking about even more modifications. I'm sure you know how it goes. This is running on a ELF membership card on a 1802 with bit banged serial, so it's not particularly fast. And one of the things that Glenn had put in here was a way to load some extended functions very easily out of the ROM. That's the BLOAD command. And I am going to tell it that I want to upload a file using the ELF4th protocol, and I'll show that in just a second. And I'm going to load in temp capture text. And that gave me a bunch of different words. And I'll show you some of those words here in a second. So the way I did the file transfer to keep it from overrunning, if you look and you configure Minicom, this is under Linux, of course, the file transfer protocols, there's ELF4th, which that's just an arbitrary name, and it uses my ELF2K exfer with a couple of different parameters here. And what that does is it waits for the character to be echoed before it proceeds to another character, so it's as fast as it can be as opposed to just putting a delay in there. And then it waits for the OK character to come back from fourth before it goes on to the next line. So in that way you can go pretty much as fast as is feasible without having to have long random delays that might not be as fast as possible, or overrunning the thing, which would be even worse. So let's see what we've got here. First of all, very conveniently, you can do things like see a variable. Okay, and that's something you could capture in your terminal program. And that says, well, create a variable called base, and then 0#10 base and store. So that would restore that variable if you loaded all that in. The 0 pound is decimal. You don't have to do that, but you can. And when you do something like this to save, it marks it as decimal or hex so that when you bring it back in, it doesn't matter. So in other words, even if we were in hex mode, it would still be 10 decimal because of that pound sign. So for example, though, I can write OX16, and now that's 22, right? Or if I were in hex mode, now it's 16, but I could have just as well written like that. So either way you go, works well. The other thing that you can do is you can list all the words that are in the user dictionary. And so that includes the variables and everything else. And of course, some of these were in that BLOAD. Some of them were core words that are in the ROM all the time. But look at this bottom part. This is what I loaded out of that file. There's an asympcode word that we're not going to use right now, but I'll show it to you in a minute. And then there's a variable called MLAA with 2 extra words in it. And then it goes on to populate those words. So E364 gets stored in the first word, AAE2 in the second word, which is 2 bytes over. These are byte offsets. D500 gets stored in the last word. And so that's a little machine language program. It basically sets the X register to 3, outputs an AA to the LEDs, sets the X register back to 2 so as not to upset everybody, and then does a return. And that 0 is just an extra because it's a word size variable and we don't have an even number of bytes. So then there's an ML55, same thing, except instead of the AA, we've got a 55 here. And then there's words for those. There's HWAA does an MLAA, which is the address of this variable, exec, and then drops the return address. Same thing for HW55, ML55 exec drop. And so if I want to put AA on the lights, which of course you can't see, I can just say HWAA, for example. Now, granted, you could have done that without using machine language. I'm just trying to make a point. But anytime that you do a C on any of these variables, you'll get that same format. So that can be just captured and fed back into Forth later, and you'll reconstitute that particular variable. And same way with the words. If you say C a sim code, for example. So the fact that that's saved means I don't ever have to enter those machine language routines again. But if I did want to, this sim code's kind of a simple way to do it. You can give it an address. So in the case of like the MLAA, let's go ahead and redefine that one again. If I said MLAA, that's the address. And then I said, I want these bytes in it. I want E3, 64AA, E2, D5. Now notice I put them in the order I want them, not in stack order. So it's going to go backwards from that. But in order to do that, it needs to know how many bytes are here. So there's 5 bytes. And then I'm going to call a sim code. Now, if I were to say MLAA, say 10 dump, and there you go, E364AA E2D5. So pretty interesting set of additions. The hex and decimal makes a big difference when you're saving stuff. Being able to save variables as things you can load back in is a big change as well, and being able to call machine language programs pretty easily. And you can also use that to call into the BIOS. You do have to be careful about what gets destroyed, and it's just a standard SCRT call. So, you know, your normal setup, stack pointer on 2, program counter on 3. To do a return, just like you see here, you do a D5, which is a return. And whatever's in, I believe it's the A register, gets put on the stack. So if you notice, these drop the result that comes back from exec, because in this case we're not actually returning anything anyway. So great fun, been enjoying playing with it. Hope you get it built and enjoy it as well. Thanks for watching.